All right. I think we will go ahead and get started. So thank you so much for joining us. Happy National Biomechanics Day. We have the Vicon support team, some members here to present for a special Biomechanics Day ProCalc webinar session. So obviously you're here for the live session, and that's great. We have Mike here, who's going to be presenting on ProCalc as a teaching tool. We also have Felix, our life sciences product manager for the Americas, who will be here to answer any questions that you might have. So the Q&A section is open. You can submit them throughout the presentation and we'll get to them at the end. And then we also, of course, have the poll that I just launched. This session will be available on YouTube immediately after, and you'll also be getting an email with the link in your inbox 24 hours from now. So with all that being said, I will go ahead and hand it over to Mike.
Hi, everyone. I'm Mike Brayman, as Alicia said. I'm a life science or senior life science engineer or application engineer on the life science side. Just a little about myself, since it's National Biomechanics Day, and how I got into this. So I kind of got introduced to the world of motion capture when I was in grad school, doing research in a gate lab. I was getting my master's degree in biomedical engineering, doing mostly like walking studies and whatnot. And then after that, came to work for Vicon. I've been here for a little over 5 years now. So with that, let's go ahead and get started. I'll go ahead and share my screen here. Oops. Yes. Just want to share my. There we go. Okay, sorry. All right, so I've got a little slideshow here. We're gonna stick to, we're gonna be in ProCalc most of the time, just because I don't want, keep it more interesting and whatnot. But I do have a couple of slides to kind of introduce stuff. So, anyways. All right, so what we're gonna get into today, we're gonna talk about how ProCalc can be a valuable tool for teaching, for a lot of things, but trying to focus mostly on teaching today. So for some of you, you might be brand new to ProCalc, so you might not be too familiar with it. So I'm going to start with a brief introduction. Where does ProCalc fit into your motion capture workflow? What can you do with ProCalc? And then why would this be a good tool for those applications? So I'll start with like a little bit of a ProCalc overview, just the requirements to run ProCalc, talk about the layout, and then the different scheme types within ProCalc. And this will be real brief because I want to spend most of the time on the application. So we came up with just a real simple example biomechanics problem, one that maybe you would give to like an undergrad student as they're being introduced to the software and to biomechanics in general. So we start simple with a simple angle, then get into a more complicated 3D angle. And then finally, we want to pull some parameters out of that model that we just created. So with that, let's go ahead and get started. So first, that first part that might be kind of unclear to you if you haven't used ProCalc is where exactly does this fit in your workflow? There's a lot of people are pretty familiar with the kind of the beginning of motion capture workflow. So we have a subject. Usually we have a marker set that's already been determined. We might have determined it, or perhaps maybe you're a student and you're just being taught by your advisor, where the markers go. And then we know kind of how the processing works in Nexus. We're trying to get labeled trajectories, so we apply labels. Then we typically will we might do some more processing steps like filtering and gap filling and whatnot. And then, we'll run our model. And for a lot of people, this is a little bit of a black box. And so I've got a screenshot of Nexus being shown here and just the plug and gate bones and just like the graph outputs that you guys are probably familiar with. So a lot of times, we'll run this model. We don't really know what's going into this model or what really affects the model. We might not know how even marker placement affects some of these model outputs. And I've even seen it, this kind of black box extend even further to even include some of this, labeling. I don't know if I have this set to auto advance or something. That is surprising. Let me go back. Or maybe I hit my scroll button. I'm not sure. But yeah, I've seen this even extend to kind of the labeling part, because people will even confuse the labeling template as the model. So they'll actually be looking at some of those template outputs, those joint outputs that you can actually see in Nexus, and they'll actually think of that as the actual model, or they'll refer to the labeling template as their model. So there's definitely some confusion, especially with new users, as to what's actually going on here, and what does a model really consist of. So that's where ProCalc is a great option. So with ProCalc, we have some existing models that download with it. We can create our own models. We can go through the practice of creating your own model. And ProCalc's really great because, as you can see down below, we have a screenshot, and you can see all of the different outputs, and you can visualize these on the screen. So that is a great tool, and I'll talk more about that as we kind of move forward. So kind of real quick, what is ProCalc? So ProCalc, it's a wizard-based modeling tool. What we mean by that is we've got a nice graphical user interface. So no scripting is needed or anything like that. It prompts you for inputs, you select everything. And generally what we're doing with it is we're creating and applying custom models, or just even custom calculations. So it could be custom, maybe an animal kinematics or something like that, where we don't have a model yet, or it could be just calculations we might be adding to to an existing model. It also has some event detection capabilities as well. So it has just basically more advanced event detection options compared to Nexus, because we can do that in Nexus, but you can calculate events based on certain parameters or conditions that you might want to use. And then you can actually calculate key parameters. So one quick example is you might be looking at maximum knee flexion values or something like that. You can find that in Nexus, but there's no way to automatically pull that data out. And then one of the big things we'll hit on as we go, and why we think it's so good for teaching and whatnot, is you can actually visualize everything. So you can see there's an angle that we've actually calculated from and this is originally a plug and gate template, but we've calculated this bike application. You can see this angle between the torso and then the peak and the knee when it's at its peak, or when the hip's at its peak flexion. Just different outputs that may be interesting to you. So, all right. All right, and then the next one we'll talk about why do we think ProCalc is so good for these applications, for teaching, for learning. And the big thing is, one of the biggest ones is there's no scripting needed. So one of the most, I'd say a lot of people, will use MATLAB or Python to generate these model outputs. If you're new to biomechanics, learning biomechanics is enough without having to learn a scripting language. And it's just easier to run because you can see everything in real time. So you're not running a script and debugging. ProCalc also prompts you for inputs. So if you're not really sure how to go about creating an angle, you'll see, as you can see in this screenshot here, you can see it actually is prompting you for the different inputs that it's looking for to define these elements that you're creating. And then you can instantly visualize things. So I've got a femur segment shown here. You can see the axes on there, so you can quickly change things. And you can, if it's not the way you had it visualized, you can easily update it and make changes. You don't have to go back, edit your script, run the script, save it, run the script again, and then see if, hopefully there's no bugs that you have to debug, and then finally see your outputs that you've created. So All right. So real quick, let's talk about some requirements in order to use ProCalc. So first and foremost, you need a valid Nexus 2 license. So they operate off the same license, which is great if you're already a Nexus customer, because you get this really highly capable modeling software included as well. You need to have your markers labeled. Any other processing that you might want to do, so gap filling, filtering. If you could even put events in there, you can do events in ProCalc as well. But then ultimately, you'll want to have everything saved in the C3D file. So you do need a C3D file to open up anything, or ProCalc will only open C3D files. So it's not like you can open like raw data in there or anything like that. So let's talk real quick about the ProCalc layout. On the left side here, we have our controls. So this is pretty similar to our database management in Nexus. It's really pretty much exactly the same. The one thing that you guys might notice differently is we have these, we can specify these schemes that we want to run. We can actually process trials from here. And then next on the right side, we've got our 3D workspace. So this is where we would visualize anything that, we can visualize we can play our trial in here, and any like elements that we created, we can visualize in there. And then finally, we have this output log down below that will actually output any of those calculations that we've created. So we can see things in real time and see those values in real time, see that things are actually, working the way we expect them to. So, all right. So we're going to get into our application here, and we're going to try and we're trying to kind of thinking about this, about how, if you had if you're trying to teach someone new to biomechanics, kind of how you would go about creating, collecting data and kind of solving a biomechanical problem. And so we came up with something just really easy. We're looking at knee kinematics during a drop jump. So we're going to start real simple. So we're going to just measure knee flexion with a simple angle. Then we're going to expand upon that and create a 3D joint angle. And then we're going to get some parameters out of it. And then we're going to look at maximum knee flexion during the drop jump and then at impact. And we can certainly make this a little bit more complicated. If it's, I would kind of picture this for like maybe an undergrad student that's new to it. But if it's more research-based and grad student level, maybe you'd want to expand upon this and say, perhaps like we're going to look at provide some sort of like return to play application. Like maybe we want to look at like knee rotation before injury and after injury of some data that we've already collected or something like that. So we can definitely get more complicated with this as we go. So as someone's new to biomechanics, this might be how they think about a knee angle. So pretty simple. If we have a line or a vector representing the femur, and then another vector representing the tibia, and then the angle is just that angle in between here. And it's really simple for us to do this in ProCalc. You can see it on the right side. I'm actually going to do it in a second, just to show you guys how easy it is. And you can see everything visualized nicely. I had one of my colleagues, Nev, actually volunteered to do the same thing in MATLAB, and he's pretty proficient at MATLAB, so it didn't take him that long to knock this out. But he did end up somewhere around like 75 lines to do this same thing. So I'm quite certain that I'm going to do this a bit faster than what it took him to do this in MATLAB. And that's for someone that is an experienced MATLAB user. Another, to hit on that point again, just getting these simple calculations out quickly and not having to worry about learning a language, writing a script, debugging a script, it makes this extremely valuable. Whoops, I didn't want to move there yet. So let's switch over to ProCalc. There we go. Okay. before we go into ProCalc, I'm actually gonna give you guys a quick little tour. So as I mentioned, I think I showed you guys this screen earlier. And so we've got our 3D workspace, output log, database management. We have a few other tabs that we're not going to quite touch on this, so I'll quickly talk about those. So we've got the input parameters, and these are really any constants that you're going to use. I've got this Conga scheme actually downloads with ProCalc, and it's very similar to plug and gate. So you'll see a lot of the same really the same plug and gate parameters. But yeah, it's any constants you might want to use within your model. So you see body mass, and then even stuff like pi there is there. So variables is really time-based calculations that you're trying to make. We're going to spend quite a bit of time in there, so I won't spend too much time now. And then events, I mentioned we can specify events based on a criteria. So you can see here where they're identifying like mid swing here. So, and then finally our parameters tab. So we can, if we're looking at certain parameters such as like knee flexion at a point or something like that. And this, you can see all these spatial temporal parameters that you guys are probably familiar with that you can calculate within that. You can calculate within Nexus and even within Polygon. So, and let's go back to this variables tab. And I'm just going to go ahead and add a new one. So I'm going to do simple knee angle. And actually, what I forgot to do, I wanted to go into my knee angle data. So let's back out. Got a little bit switched around in my workflow. So I apologize. So we're going to open this drop jump. All right. So here's the drop jump data with that simple knee angle. All right. So I'm going to go right back to that variables tab into that that scheme that I already created. I'm going to click at it. And then I'm just going to add that knee angle that I wanted to calculate. So, and what I'm going to do, I'll select angle. And you can see I've got a lot of options here. If I wanted my 3D angles, you can see those down below with the Euler angles. But I want a simple one, angle between A and B. And then here's what I mean about how it prompts you. So I can see right away, with this angle between A and B, it's looking for vectors. So if I click on the drop down, you can see I don't have any vectors that I've defined yet. So I know, okay, I need to create some vectors. So I'm going to go add. I don't even need to finish that one. I can just start a new element here. And I'm just going to create a right eye vector. So change the function to vector. And then I'm just going to define it as point A to B. And then the great thing is I can just click on the markers in the 3D workspace. So I don't even have to really know. Well, it's helpful to know marker labels, but I know I can I have the right one just by choosing them in the workspace. So there's my right thigh vector. I've also got the right tibia that I'll create. And do the same thing, my knee to my ankle. All right, and I've got those two vectors created. And now I can go back into this knee angle. I'm going to select vector, right thigh, tibia. All right, and there I've got an angle. Now I don't know if that's really the angle I'm looking for. It is, it's probably in this case would be what the supplementary angle, I believe. Perhaps, I don't know. Either way, you can see it's positioned that angle kind of in the wrong spot. That's how I would traditionally think about it for that knee angle. So even though the values are probably in alignment with what would make sense, what I really want is the angle right here. So if I keep that in mind, that if we're it'll typically stick this the actual like angle at the tail end of the first vector, you can actually go in here, and I don't know if you guys noticed this, I didn't point this out, but there is like a little arrow there that shows you the direction of the vector. But I can actually just easily change this. So if I go back to that right thigh vector, I can select the right knee and then the right greater trochanter, and you can see that that vector direction has changed. Now if I go back to my angle, there we go. So now I have an angle that is similar to what I had in that in the PowerPoint slide. So so some of you that are experienced biomechanists might be thinking, well, that's not really the way I think about knee angle, right? So typically when someone's standing, their angle should be closer to 180, or sorry, closer to 0, not 180. And then as you would flex your knee, your angle would increase, not decrease, right? If I want that to be more consistent with how I would typically think about this, I can also easily change this through these factors here. So what I'll do, I'll just negate this one, the tibia one. Actually, I think what I would rather do, maybe I'll try that thigh one. So, there we go. And that's probably more in line with what you would typically think about for a knee angle. So you can see as they flex, we get to about like 70 degrees. So now if I wanted to output this to a C3D file, all I need to do is check this little box here. I can output that into a C3D file, and then I can just save it up above here. And at this point, I could go ahead and process the rest of my data with this and get this knee angle fairly simple. So let me back up a second, and we're going to go back into that presentation. So you guys can see just how easy it was to get to this same spot that I had shown you in the screenshot versus the time it might have taken me to script something like that. So the simple angle might be a great start to someone that's new to biomechanics, but as we all know, it's really not doesn't include everything that we need for most biomechanical analysis. So most of the time we're looking for 3D angles. So a simple angle doesn't give us any information on like the rotation or if there's like some varus valgus occurring. And a lot of times those little details are what we're interested in as researchers. So as I mentioned, like maybe you're doing some sort of return to play after an ACL tear or something like that. And you're looking to see if there's some excessive amount of knee rotation or something like that. So ultimately what we're usually after is a 3D angle, and Euler angles are what's most commonly used in the life science world. So, so that's what we're going to go to next. So the great thing about 3D angles in ProCalc is it makes it the visualizations make it very obvious what angles we're talking about. And we'll see it, once we actually start creating this ourselves. But you can see the different colors on the grass that correspond to the different fans on the actual subject that show those angles. So it's very clear versus in Nexus, I've got kind of the same thing being shown here. We can see our grass and we can see our axes, but there's just not as much visualizations going on there. And then if you were to compare this to scripting, I mean, yeah, with scripting, you can end up at this point. But again, it's going to be lines and lines of code and all that. So it's definitely a lot harder as a teaching tool, or, if you're trying to learn biomechanics to do this with a scripting based software. So with that, let's go ahead. Oh, I guess the other thing I wanted to touch on, and the other nice thing that's helpful, even if you're using an existing model, that I think is really nice about actually running through this practice is, a lot of times we are given predefined marker sets, but I see a lot of people struggle when they're trying to track something new or capture some new type of motion. Maybe it's just something like a robot or something, on how do we develop a marker set. So when we start going through this process of creating these models, we start to think more critically about where we're placing markers and why are we putting markers in this spot. So we don't just, when we're using something like plug and gate, a lot of people just kind of accept it as it is. So they don't think necessarily about how marker position changes these outputs and how it is used to define these variables we're calculating. So it's a great exercise to go through and actually create these elements yourself. So let's go ahead and hop back into ProCalc. I'm going to navigate back to the data management, and we're going to back up into our drop jump cluster. So, all right, so we've got this marker set that we've created here. It's somewhat similar to plug and gate. We've added medial markers and then some clusters on the thigh and tibia. And then I'm going to jump over to the variables tab, and I'm going to navigate to this scheme that there's actually been quite a bit of work already done on this. Nev actually started this scheme, and he's already defined the pelvis and the thigh segments, and then actually gotten a hip angle. And what we're after again is that knee angle. So we haven't defined the tibia segment yet. So let's just go ahead and jump right into this. So I'm going to edit this. What I'll add is my right knee angle, and I'm going to go with angle. And then, so what I'm going to go with, I'll just, this might be a little bit confusing for you. So let's just go with the first one, Euler angle, XYZ between A and B. Right now I can see right away it's prompting me for segments. I know I've got my femur segment. I said we already created that. I don't have my tibia segment yet. So let's go ahead and do that. I've gone ahead actually and created some vectors already for our tibia segment and some joint centers. So just quickly to kind of explain what I'm doing. If I look at my femur segment, you can see that the origins at the knee joint center, and then I've got the z-axis extends up to the hip joint center, and then the y goes medially to the medial marker. So I'm going to do something similar with this tibia segment. So I've already actually defined my ankle joint center. It's just the midway between the medial and lateral malleolus markers. And I've even defined those vectors already. So I've got a proximal distal vector, extending from the knee joint center or the ankle joint center up to the knee joint center, and then a medial lateral vector that's going from the ankle joint center to the medial marker, just like I did with the thigh segment. So let's go ahead and create that tibia segment. So right tibia segment. All right. So these first options are if I just were specifying points, and it would just like create those vectors for me. So I've already created the vectors, as I said, so I'm just going to go right down here. So they're all, the first one entry is going to be the origin marker. And then the next one is going to be, I can choose whether my next vector is going to be the X, Y, or Z. And I'm going to start with the Z. I mentioned that's going to be that, distal proximal vector. So I'll do Z-axis is B, and then X-axis is going to be B crossed with C. So I'm going to go ahead and select that right ankle joint center. And then I'll choose those vectors. So right tibia, distal proximal, and then my medial lateral vector there. And now you can see that I've got a segment created. Now, if you guys can recall, if I go back to my right femur segment, you might remember seeing that that it was actually rotated 180 degrees. And this is actually kind of a great lesson in cross products here, because it's going to determine that x-axis is going to be the cross product of those vectors B and C that I specified. So if I think about the right hand rule, I've got this vector is actually going to my medial joint, and then my z vector is going this direction. So if you think about the right hand rule, that cross product is actually going to go posterior for that. The cross product for that x direction is going to go posterior. So so this is another like great little lesson here, because I mean sometimes cross products can be kind of difficult to understand. So you can this is, if we can play around with that, we can even find cross products within ProCalc. So just to understand how like vectors and cross products work, you can visualize all this stuff in ProCalc, which is great. So so this is pretty simple. I can fix it two ways. I can either change the direction of that vector by going back to that mediolateral vector, or I can just simply negate this one, and you'll see it'll flip around. All right, now that aligns with what we're looking for in the femur, or with what the femur axis was. So yeah, so let's get back. We've got our tibia segment now, and I can go back to my right knee angle. And so yeah, I've got my angle selected, XYZ between A and B. We're just going to select that child segment, which is that right tibia I just created. And there we go. So there's my Euler angle. Now, you can look at this and you can see green is that flexion component we're kind of looking at earlier. Now the color scheme actually matches with Nexus. With red is our first component, green is our second, and blue is our third. So it would be, red X, green Y, blue Z. And now typically when we're defining the rotation, we just chose the first one. We want that first component to be our major axis of rotation. So we would actually want that the flexion to be the red or the X value, which is occurring about the Y axes of those segments. So what I can do then, if I know that piece of information, I can actually choose this more appropriately. And then, so what I'll choose then is I want a Y first. So Y is going to be my first axis of rotation, then X, so that'd be like your varus valgus, and then Z, which corresponds to what like plug and gate typically, or what plug and gate does. And there we go. So that's more in alignment with what you would see at a Nexus, and what typically you would want, how you would want this to be set up. So it's great, as I mentioned, visualizations the entire time. I can see these outputs here below, the three components. That red one is, again, our flexion, our primary, our axis of rotation. And you can see how it changes as we scrub through here, and you can actually see the values change. And then you can see the blue fan as our rotation value, and then the Y one, which is really small, is actually the varus valgus within the knee. So you might be thinking, looking at this graph, okay, I've got, that looks better, but my knee angle is negative, which is not typically how I would think about this. So I can actually easily fix this. So we have got this negate option here. We can negate any of those elements. So what I want to do, I'm going to leave the varus valgus and rotation alone. I'm just going to negate that first one. So I'll do negative plus plus. And there we go. So now we're looking at around 70 degrees again, around the same as the simple angle calculation we made. But it's certainly more accurate considering we're actually using joint centers and less of a 2D approach. And we also now have rotation and rotation in blue, and then varus valgus in green. So and again, if I want to output this to the C3D, I can. I would save it, and then we're actually going to run this in a second. But before we do that, let's go into the parameters. So I mentioned, part of this. I'm just going to create a new one. Part of this exercise is you might want your students to come up with some parameters. In this case, we're going to keep it real simple. We're just going to look at knee flexion, but perhaps you want to get parameters from a couple of different trials with someone pre and post injury, and see how like the rotation changes or whatever, or compare, an injured group to a normalized data set or something like that. Either way, we're going to need to pull some parameters out. So let's just do this simple drop jump parameter. Because I didn't end up deleting the original one. Okay. All right, so I'm going to do a quick parameter here. What I mentioned was, again, real simple, maximum flexion. And you can see we can get a bunch of different, we have a bunch of different function options out of here. In this case, we're just looking for a value. So we just want that one value, that maximum value. And we're looking, again, maximum. So we can do it at events, which we'll do in a second. Variable A, max A, and then A. For the type, we are looking for that Euler angle. And then we've got that right knee angle that we created. And in this case, I'm just gonna, choose the X component. If I wanted I could choose all of them, or, if I just wanted rotation or something like that, I can obviously do that. I've already defined these events in Nexus. So in this case, I've got heel strike as landing and then toe off as when they actually jump off the plate. So I'm going to define event A as right foot strike, event B as right foot off. And so it'll give me that maximum value between those two events. And there you can see down below, around 72 degrees, which is, again, what we were kind of estimating as well. So the great thing is I was able to come up with this pretty close to this visually myself, but I can now use this to process the rest of my trials. And I can even export it to an Excel sheet, so I can get everyone in the same Excel sheet. So I've got all my parameters. I'll do one more. We're going to get flexion at an event. So like that. Again, I'll keep it value, and then this would be just variable A at event A. Let's see here. And right foot off. Oops, sorry, chose the wrong one. Right foot strike. There we go, 35 degrees. So that's at landing. And that is it. And again, if I want to export it to Excel, I can do that. Now I can just save that. And at this point, I'm ready to actually run these schemes that I've created. So if I go back to my data management, I mentioned that I can run schemes from here. I'm gonna, I didn't do anything in the input, but for the advanced, but I'm just gonna run that that NBD 2020 hip angle, the one I modified, and then that drop jump too. So if I right click on the trial I want to process, same one I had open, I'm just going to mark it, and then I can process smart trials. And I can do multiple trials here if I wanted to. And now you can see it actually ran through, export those to the files. If I were to open this up in Nexus now, open up drop jump 01, and I go into my subject tab, I can actually see those angles that I've created. Here's the knee angle, and then under the analysis outputs, I've got my parameters that I calculated. So I mentioned those parameters can also be taken, can also be saved to the Excel sheet. So there we go. There's the Excel sheet. And what you can see is actually just writes it right on top. So if I actually processed these a few times, so if I were to process like multiple trials, I would see them all listed here, so that I can easily pull all that data from there. So yeah, and that's kind of a quick demo of kind of how we might want to use this. So you guys might be thinking about, okay, well, what's next here? So that was pretty basic. Is there help out there? And the answer is yes. So one of the great resources we have is our YouTube tutorials. We do have a ProCalc playlist on there. So you've got that link there. Easily you can just find it in our Vicon Life Sciences channel. We also have a main Vicon channel. So both of those have a playlist for ProCalc tutorials. We also have some tutorials in our docs, in our documentation. So there's a lot of great info in our documentation. There's a few tutorials you can work through as well. One specifically that I found really helpful was it's like a 6 Degrees of Freedom tutorial. And when I was getting introduced to ProCalc, that's how I kind of began to learn things. So, it's really great. It kind of walks you through each of the tabs. And I think a lot of the main principles that you need to know to get started are really, really helpful. So, and then lastly, if if you're stuck, don't hesitate to reach out to us. So our support email is support@vicon.com. So feel free to shoot us an email. We're usually pretty quick to respond. We love talking about stuff like this. We all have backgrounds in it. So, it's great, especially since it almost seems like we don't get ProCalc questions too often. So I think it's a really fun software to play around with. And we always love seeing what people are doing with it and helping out when we can. So, and then with that, I think I'm going back over to Felix, and we might be doing some Q&A. So.
Absolutely. Thanks, Mike, for a great presentation. We've had quite a few questions come in through the Zoom chat as well as through YouTube. So I'm just going to start firing them off, Mike, if you're ready. Again,
I think I'm ready.
Be specific about ProCalc. So if you guys do have some questions, please feel free to send them over. The first question, actually, a couple were answered through the chat, and I think Mike did kind of answer these as we kind of go along. But I think it's worth kind of reiterating what some of these answers are, because it's probably questions that are on the top of everyone's mind. So first one is ProCalc free to use if you have the Nexus software key?
Yes. Great question. It is. They do work off the same license. So yeah, if you have access to a Nexus 2 license, whether it's just a network license that you might access or community license even, you will be able to use ProCalc. So that, like I said, I think it's a great value to get that for free, considering that you can pay quite a bit for other modeling softwares out there that have similar capabilities. So.
Good. The next question we have is, are there any current future plans to extend ProCalc capabilities by integrating scripting? And upon digging a little bit more into this question, it's more about trying to import in custom calculations or equations.
Well, I mean, if you have custom calculations that you're performing elsewhere and saving as model outputs, all those will show up in ProCalc. I don't think there's anything in the plans to add any scripting capabilities to it. One of the things that will be added soon is a little bit of a teaser, is we don't currently have kinetics in ProCalc 1.5, but that will be coming soon. So that is a nice new addition that we're all looking forward to.
Okay. And you kind of answered this one near the end, but is it possible to have ProCalc run as a pipeline?
Yes, yeah. I didn't actually show this within Nexus. I can actually show you guys real quick. But if I were to go into, I'll just add it to this one. So in the data processing section, there is a run ProCalc operation. And you can actually see, if I go to that variable scheme, I should see yep, there it is. So there's that scheme that I was editing earlier. So I can actually run this within this pipeline. I can even use batch processing within Nexus to run all my ProCalc schemes. So yeah, having that functionality does make it easy. We can just add it to our existing pipelines and really quick speed up processing. So.
All right, next question. We have, I work in an animal with an animal model where we do not have a knee marker. The skin over the knee moves too much during gait. Instead, we use another marker on the tibia to triangulate the knee position. Could I still use ProCalc to do this?
Yeah, so you certainly can. There's definitely a few different ways to go about this. I know I've had, like in some cases, people want to use something like as a virtual marker. So there is a way that you can, maybe you have like a static trial where you could even use like a pointer or something like that, or where you can initially place that knee joint center if you need something like that. And then you could save that as a parameter that you would save that local transformation, that local to global transformation as a parameter. So then you could then regenerate that virtual point in your dynamic trials where you don't have the pointer. But yeah, there's definitely more than one way to do it. If that's not exactly what you're thinking, you can always reach out to us, and so we can understand a little bit more about how you're doing it currently. But there's definitely a lot of different options for generating those points within ProCalc. So.
And you just answered this question, but again, it's probably worth reiterating. What about kinetics?
Kinetics is coming soon. So in ProCalc 1.6, we're adding it. We can get, as is right now, we can get center of pressure data out of the force plates, and we can even get force vectors, but we don't have any way to do, in ProCalc 1.5, there's no way to actually get kinetics. But like I said, coming soon 1.6, all those capabilities will be added so we can get those joint forces and moments and powers and all that good stuff. So. All
right, we've got a question that's about specific operation within ProCalc. It says, if I've set up something for one side, do I have to repeat everything for the other side if it's pretty much the same?
That's a great question. So I actually didn't show you guys this. There's this mirror function within ProCalc that also makes it really simple. So if I go back and edit this script, I'll start with, why don't we just do our angle joint center? So if I go ahead and copy this, you can see it creates a copy, and then if I hit mirror, you'll see it'll actually switch. So it even recognizes that right and left that I did, and then it switched to those left side markers. So then I would just go about doing this exact same thing. So same with like those vectors that I wanted to use. Just copy mirror, there's my left tibia vector. You guys can see. Oop. I don't know why that's not showing. I wonder, did my other one show? That's kind of weird. There's my left ankle joint center. So the one that I just created. So.
And so then the next question is, can you do conditional calculations? I'm assuming like if this exists, then do this.
I guess there is, let's see. I think there's a lot more conditions. Let's see. We do have like conditions as far as like timing goes. There is quite a few different ways that you can bring things like that in. I think a lot of the conditions might go within the events. Is probably how I'd handle that. So like with an event, I could make a condition like, you have to be, I don't know, like at a certain speed and beyond this point or something like that. And then maybe I would calculate, I can make my parameter then that I'm calculating, instead of continuous, I could have it in between different events here. I think, so that's kind of what I'm thinking when I hear like conditional calculation. So I think that's kind of getting at what you're aiming for in that question, if that makes sense.
Excellent. Okay, so we have some more questions coming in. I see that Nexus integrates Thea data. Can you process that in ProCalc?
Yeah, so there is actually a Thea ProCalc scheme. I don't know if I've got it in here actually. Say that. I don't think so, but there is a Thea ProCalc scheme that we'll use. So after the data has been processed in Thea, instead of like the alternative workflow is instead of going into Visual 3D is we can run it via ProCalc. So there is a scheme available that does calculate those all those kinematic variables that you're looking for in Thea. So I guess the short answer is yes. So.
And you kind of answered this one a little bit, but are there any sample tutorials or schemes that I can use to kind of practice?
Yeah, so I mentioned the tutorials are on our YouTube channel. They're also on our docs page, so there's all that. Some of these, I've got a lot of different schemes here that I've created, but some of these do actually download automatically with ProCalc. So one is there's the Congo one gets downloaded automatically. So that's a great one to look at if you're trying to understand plug and gate more. As I said, it's based on plug and gate. And there are some more example schemes on our website. So if you go to our downloads page in the models and scripts section, there are some. So there's that bike fit scheme that I actually showed a screenshot of earlier. This won't, it'll all be red because I don't have a biking trial open, but yeah, if you can get that bike fit one, and then you can also, there's a drop jump one as well. So that would be a great one to look at, especially after what we just, the example we just went through. So it'd be looking at the same motion, but it would, taken quite a bit further than what we did with calculating the parameters and stuff from that drop jump and all that. So yes, they're on our downloads page. Check them out. If you have trouble finding them, let us know. So.
Then kind of an extension of the Thea question, can it do, we'll also be able to do kinetics with Thea data?
So I think that will only be possible with once ProCalc 1.6 comes out. So I've done somewhat limited Thea testing with it, but I would think that would functionality would be added with 1.6. So.
And then kind of an extension of the first question that was kind of asked is, I filter my data using a custom MATLAB. Will I be able to still use that data in ProCalc?
Yeah, so I mean, so typically with MATLAB, you've pulled the data out, do your processing, send it back in. So it's going to be saved in, I guess it depends on how you end up saving it to the C3D file, but yeah, it should be, visible just the same as your normal data, as your original data within ProCalc. So.
Awesome. Well, that seems to be all the questions that we have. Again, I want to thank everyone for coming to celebrate National Biomechanics Day 2022 with us. We hope to see you guys all at a conference soon where we can actually meet in person. But as Mike says, we have great resources on our YouTube page. Please contact support, and we will continue to also put out more and more tutorials and resources to help you guys get more comfortable using ProCalc.
Yep. Thank you everyone for joining. Yeah, we look